Okay, so this is what we mean by tables. So remember, with our spider diagrams, we had on the left-hand side all of our inputs, and on the right-hand side, we have all of our outputs. In this case, the inputs will be located at the top of the table, and my output will be located at the bottom of the table. So it says for each output, multiply the input by 4 and then subtract 5. So firstly, let's write that into a nice equation. So for each output, which is y, you multiply the input by 4, which means you're going to say 4x, then subtract 5. So say minus 5. Okay. So if you look here, let's test it with the first one. With my first input would be y equals 4 times 2 minus 5. How much is 4 times 2? We're just testing out the formula that they've given us now before we use it for other calculations. So how much is 4 times 2? It is 8. Thank you, Nhlamulo. And if I minus 5, how much do I get? 8 minus 5. I get 3, which is my desired output. So that formula is in fact correct. So now we're going to use it to find A and B. But in this case, if you look carefully, A and B are inputs. They're located at the top of the table. So they've given us Y and they're asking us to find X. So in the formula that we have now written down here, am I going to substitute 35 at X or am I going to substitute it at Y? In this formula that we have on the side, will I substitute my 35 where I have an X, or will I substitute it where I have a Y? What do you guys think? X is Buhlali. Does anybody else have an opinion? Welcome, guys, everyone who just joined after I greeted. Where will we substitute that 35? Look where it is on the table and let me know where in my formula am I going to substitute this 35 over here. This one. What do you guys think? Everyone says X. Okay, according to this table, is 35 my input or my output? Look at where it is in the table. Is it my input at the top or output at the bottom? It is output. So then if output is denoted by Y, where actually am I supposed to substitute that 35? At Y. So you guys have to look carefully. So then I'll substitute it where I have Y. So that means 35 equals 4x minus 5. Now, we want this x over here. How will I get this x on its own? Let's start with this 5. I have a subtract 5 over here. How am I going to get this x on its own? How will I get rid of this minus 5 over here? Bring it over, and once I bring it over, what happens? 35. Nice, Seth. It becomes plus 5. So then we have 40 on the left-hand side equals 4x. We have successfully gotten rid of that 5. But now I still have a 4 in front of my x. How will I get rid of that 4? How will I get rid of the 4 that is in front of the x? Anyone? Nice or funny? I'm going to divide by 4. But if I divide on one side, I must go and divide on the other side. So these will cancel out. Therefore, x is equal to 40 divided by 4, which is 40 divided by 4. So that means my input was 10. Nice, Logan. So for an input of 10, you get an output of 35. Now let's see what the input for B is. Okay, let's see what B is. Again, 55 is at the bottom, which means it's our output. So I substituted where there is a Y. So it's 55 equals 4x minus 5. Once again, I want to get rid of this 5 that is next to it here. And I'm going to bring it over the equal sign to the other side. Once you do that, it becomes positive. If it was negative, which it was in this case, it becomes positive. So it's 55 plus 5 equals 4x. 55 plus 5 is 60 equals 4x. Divide by 4 on both sides. What's 60 divided by 4? Therefore, x equals 60 divided by 4, which is what? Nice, 15. So if you want an output of 55, your input would have to be 15. Okay. Let's take a look at the next example. Screenshotters, you can take your screenshots now. Remember, if you have any question at any point, just stop me and ask. Okay, don't just be lost on your own and have no idea what to do. All right. For the next one, they have given us the formula already. So my formula for this one is y equals x divided by 2 plus 4. Okay? Let us start with A, which is all the way, oh, there is no A. Let's start with C, which is all the way over here. Is C my input or my output? No, not C, 4. So they gave us a 4 here at the bottom. Will I substitute it at my X or will I substitute C at Y? Look where 4 is. Nice, Wade. It is an output, so we substitute it at Y. So here I will say 4 is equal to X divided by 2 plus 4. So this time I'm moving a positive 4 to the other side. So tell me when it gets to the other side, what's going to happen with it? If a positive 4 is brought over the equal sign and goes to the other side, it becomes a negative 4. Nice, Buhlali. So now we have 4 minus 4 is equal to x divided by 2. What's 4 minus 4? 4 minus 4 is 0 is equal to x divided by 2. Now, what's the opposite operation for division? Now we're left with a divide by 2 over here. What is the opposite of division? Multiplication. Nice, Logan. So I am times by 2 on this side to get rid of this 2. But what I do on one side, I must go and do on the other side. These 2's will cancel each other out. Okay, cross canceling. But on my left-hand side, I have 2 times 0, which means x is what? How much is 2 times 0? 0. So for an output of 4, you need to have had an input of 0. And then once again, D and E, they're all inputs. That means we're going to substitute 12 and 17 into the output part. Let's do that, okay? So for number D, I can say 12 equals x divided by 2 plus 4. We're doing the same thing. So I take this 4, bring it over, it becomes minus 4, right? So then I have 12 minus 4 is equal to x divided by 2. What's 12 minus 4? It is 8 is equal to x divided by 2. And I once again have to get rid of this 2 by multiplying both sides by 2. Okay, these 2's cancel out. Therefore, x is equal to, what's my answer for x? Nice. 60. Nice, guys. And again for E, yes, Bongo Musa?
Can I ask something?
Yes.
The 2 over 1 is always there.
No, it depends on what you are dividing by. That's the only way you can get rid of it. If you are dividing by 4, then you're going to times by 4 so that they cancel each other out. Do you see?
Yes, ma'am.
If you're dividing by 10, you have to times by 10 so that they cancel each other out. Does that make sense?
Yes, ma'am. Thank you.
You're welcome. Okay, guys, so whatever you are dividing by, you just do the opposite. You multiply by that number so that you can cancel it out. Okay, so let's continue. This time our output is 17. And this we get by saying x divided by 2 plus 4. 4 goes over once again, becomes a minus 4. So then 17 minus 4 equals x divided by 2. How much is 17 minus 4? What's 17 minus 4? It is 13. 13 is equal to x divided by 2. And before I multiply by 2 on both sides, can anyone tell me what x is? 2, 2. Therefore, x is 26. Nice, Logan. Okay. Now that we've done 2 of them, thumbs up, thumbs down on finding the input when you've been given the output. All right. Okay, I only have 4 responses. So everyone else, what's going on? Are we with me? Are we lost? If you are lost, don't be shy. Just ask a question and then I'll be able to help you. Okay, that's a bit better. A few more responses here. Okay, there we go. Okay, now we're going back to looking for the formula. We've been given an input and outputs, and we want the formula. Does anybody remember how we looked for the formula when you've been given your input and your output? Which ones do we look at to determine a general formula? Do we look at my input or output? What do you guys think? We spoke about it in the previous lesson. Do you remember which one we look at? Input or output to determine the general formula for this table. Nice, Buhlali. We look at the output. Okay? Now let's see what's happening here by output. 10 to 14. How did I get from 10 to 14? How did we get from 10 to 14? Nice word. We add 4. From 14 to 18. We add 4 again. So it seems our trend for this time is adding 4. Now, who remembers what we call this 4 that we keep adding over and over again? I had a special word for this 4. Does anybody remember what that word was? Nice word. The 4 is our multiplier. So 4 is our multiplier. Positive 4. So I'm going to take 4, times it by the first input, which is 1. What's 4 times 1? It is 4, but we want to get to 10. So what do I still have to do to this sum to get to my desired output? Nice. I have to add 6, and that will give me 10. Let's check if it works for the next one. Okay. If I say 4 times 2, what is that going to give me? 8 plus 6. What is that? 8 plus 6. My answer is 14. Is that the output that I wanted? Is 14 the output that I wanted? Yes. So what is the formula for this table? Y equals, let's write it in a nice formula. Y equals 4x, because it's 4 times x. Nice, Logan. Plus 6. Okay. Everyone who's very quiet, I hope this is coming back to you and you're sort of remembering that we did this. So it's y equals 4 times x plus 6. Okay. Okay, let's see if we can do this one. From input, this time our inputs start from 12, 13, 14, 15, 16. And my outputs are 76, 82, 88. So how am I getting from one output to the next? We said we look at our outputs to determine the rule, right? So what are we doing with the outputs in this case? What's happening with the outputs? We are from 76 to 82. Guys, how did we get there? Nice, Ronnie. Plus 6. We are adding 6. Okay. So we're adding 6 every time. So we still need to work out the general formula here, but you can definitely still figure out A and B without the general formula. How do I get from number 14 to 15? I have to add 6. So then what will A be? A will be, if I started from 88, and I just say plus 6, that'll give me 94. And B, so this will be 94. And B will then be 94 plus 6, which is 100. Great. So we figured out A and B, but I still want my general formula. 6, once again, will be my multiplier. Positive 6. Okay. So let's start the first one. 6 times 12. How much is 6 times 12? 6 times 12. 72. Is that the desired output? Look at your output for number 12. Is that the output we want? 72. No, we want 76. So what do I still have to do with this? I have to add 4. Nice, guys. That will give me 76. Let's try it with the next one. 6 times 13. What is 6 times 13? 6 times 13, 78. If I add 4, I'm going to get 82. And is that my desired outcome? Is that the output that we want? 82. Yes, it is. So my formula is then correct. Now let's write the formula properly. Y is equal to, nice, 6x plus 4. Beautiful, guys. Okay, before we go there, can we have a thumbs up, thumbs down on the last two tables that we did just now? This one and this one. Finding the general formula. Okay. Very few thumbs up. I hope everyone else is still listening and understands what's going on. Okay. All right. Now, I have 4 formulas up here, and I have 4 tables, and I need you guys to match the formulas to the tables. Okay. Now, the problem with some of these formulas is they're not in the correct form. We want our formula to say y equals something so that we're able to determine how to find x. But if you look at 1.2 and 1.3, it is not in that form. So before we go anywhere, we need to fix 1.2 and 1.3. Okay, so firstly, it says, let's start with 1.2. I'm going to do this on the side. 1.2 says 2x plus 3y equals 6. I want y to be on its own, right? I want y to be on its own. So what am I going to do with this 2x? If I want y to be alone, what will I do with the 2x that's next to it? Anyone? There's 2x. I'm going to take it over. Okay. And if it was positive 2x and we're taking it over, it will be negative. So then I'll be left with 3y on the left-hand side equals negative 2x plus 6. Now we are not done because we still have a 3 in front of the y. How do I get rid of that 3 in front of my y? The 3 in front of my y, how will I get rid of that one? Yes, but how? Because currently it is multiplying. So how do I get rid of multiplication? By division. Nice, Yonela. So that means I will have to divide by 3 on my left-hand side. But then everyone will have to get divided by 3. Do you guys see how this works? If you divide one of these by 3, you divide all of them by 3 because it's an equation. So these 3's on the y will cancel each other out. 3 divided by 3, that's just 1. So I'm left with y equals negative 2 over 3x plus what? What's 6 divided by 3? Plus 2. Okay, now we have the correct form of number 1.2. Let's work with number 1.3 and fix it. 1.3 says x times y is equal to 12. This is just one step. Okay, this is one step. How will we get rid of that x that's in front of my y? Currently, it is multiplied, so how will I get rid of it? Divide. Nice. I'm going to divide by x on the side and divide by x on the side. On my left-hand side, they will cancel each other out, and this was quick and simple. Y is equal to 12 divided by x. Great. Now that we have all 4 formulas in the correct way, let us try to match the table with the number in question. All right. So let's see. Number 1 says y equals 2x plus 4. Let's look at the first table. Okay. The only way to solve this is going to be through substitution, and we see if we get the correct answer. So if I substitute, let's say 0, I'm going to substitute 0 into 1.1. Okay. So y equals 2 times 0 plus 4 equals, what's 2 times 0? 2 times 0 is going to give us 0 plus 4, which is 4. Is that the desired outcome here? Is that the outcome we want? A 4? No. So 1.1 does not match with table A. You guys see that? Let's try 1.1 with table B. Okay. So I'm going to try it with the first one, which is number 1. Y equals 2 times 1 plus 4. What's 2 times 1? 2 plus 4 is 6. Is that the outcome we want for table B? Nope. So 1.1 is not table B. Let's go to table C. 1.1 is a problem. It's matching with none of these, right? Table C, y equals. We have another 2 times 0, okay? We don't have to do the calculation all over again. We did it. We substituted 0 already here. Do you see that? And when we substituted 0, our outcome was 4. Does that match with table C? No, it's not table C. And before we assume it's table D, you have to do your substitution. Okay, because sometimes teachers will trick you into thinking it's the last one when it isn't. Okay, so let's see if it matches with table D. I'm going to use the input of 2. So it's y equals 2 times 2 plus 4. What's 2 times 2? 4. And if you add another 4, what is my outcome going to be? 8. Is that the desired outcome? Is that my desired outcome? Yes, it is. So that means table D goes with 1.1. So we've done 1.1. For 1.2, we need to refer to the proper formula, which is this one that we found over here. Okay. Let's see. So let us substitute. So table D is out of the question. Okay, let's substitute table C into 1.2 and see if it works. So it's y equals, I'm going to work with -3 just to be safe. So it's -2 over 3 multiplied by -3, but that's always over 1, and plus 2. Okay, let's start with, where do we start according to BODMAS with this question? Where do we start according to BODMAS? We have a multiplication and we have an addition. So where do you guys think we have to start with this one? Multiplication. So we have to work out this guy over here, this part. Can we cross cancel? If you look at the two numbers that we are multiplying, is it possible for us to cross cancel? If you're not familiar with that, you can go back to the lessons we did on fractions to check if you can cross cancel. Let's check carefully, guys. Between 2 and 1, not really. But 3 and 3, guys. Do they not have a common factor? What's the common factor between 3 and 3? It's 3. And it goes into itself how many times? Once and once. Beautiful. We have cross-cancelled. Okay, now let's look at my symbols. I am multiplying a negative and a negative. So my answer is going to be a negative and a negative is going to give me a positive. Okay, now let's look at the top. We have 2 times 1, which is 2. And at the bottom, we have a 1 times 1, which is 2 over 1. I don't have to write over 1, right? So this is 2 plus 2. What is my answer going to be? A 4. Is that our desired outcome? We're doing table C now. Is that the outcome that we wanted? On table C, I substituted -3 and I got a 4. Yes, that is indeed our desired outcome. That means 1.2 goes with table C. It's fine, Logan. That's why I reminded us which table we were on. For a minute, I was like, what? All right, let's check with number 3. Again, with number 3, be careful. Remember to use the correct formula, which is over here. All right, let's check with A. Y equals, I'm going to substitute a 0. 12 divided by 0. Is this even possible, guys? Is this possible? What's the answer for dividing anything by 0? What do we write when we find something that is divided by 0? No, it's not 0. Nice. Undefined. This is not even possible. This is undefined. So is it even possible for table A to go with number 1.3? No, but as I said, you always check. Let's check table A, table B with 1.3, okay? So I'm going to say y equals 12 over 1. What's 12 divided by 1? 12, is that our desired outcome? We're over here now. I substituted 1. Is 12 my desired outcome? Yes, it is, because look there. So that means table B goes with 1.3. And before we assume that the last one goes with table A, let us substitute one of the points to check, okay? A says x squared minus 1. I'm going to go ahead and square -3. So this is -3 all squared minus 1. What is -3 squared? Remember what we said about squaring a negative number? A negative times a negative. So what's -3 squared? It is it positive 9 or negative 9? Let's see. Positive or negative? Remember, it's -3 times -3. It's timesing two negatives with one another. So my answer is positive. So this is 9 minus 1. What's 9 minus 1? 8. Is that my desired outcome? Let's look over here. Yes, it is. So indeed, we can conclude that table A goes with 1.4. Nice. Okay. Thumbs up, thumbs down on this question. What do you guys think? I'm zooming out so you guys can take a nice screenshot over here. How did this one go for us? Wonderful. Okay, I'm getting more thumbs up, which means, yeah, I'm starting to feel better also. Okay. Let's move on. Now, this is just a table where we have been given the formula. So I put this here to remind us of the rules of exponents, okay? Rules of exponents. So let's see. My formula or my rule says y equals 3 to the power of x. Let me zoom in a little bit. There we go. 3 to the power of x. Y equals, for the first input, it's 3 to the power of -2. Who remembers our rule about negative exponents? What do we do when we have negative exponents? No. Remember, we only add when we are multiplying bases with the same exponents. Nice, Buhlali. So we move it down. So this is 3 over 1, right? 3 to the power of -2 minus over 1. So we're going to take this and send it to the denominator to make my exponent positive. Is this coming back to us? So then it's going to become 1 over 3 squared. And what if 1 over 3 squared? What's 1 over 3 squared, guys? It's equal to 1 over 9. Okay, before I continue, let me check about people who were not here. Do you guys understand this rule over here that I just did? This one. If you were not here during the lessons, do we all understand that rule that I just did about moving in negative exponents? So right, Logan, at least you are answering. I appreciate you answering and the participation. I love it. Okay, so we all understand and we all remember this rule. Okay, so we can do the next one then. The next one is very similar. It has a negative exponent. So I have 3 to the power of negative 1. Once again, what do I do? This negative 3 to the power of negative 1 goes to my denominator, and then my exponent becomes positive. So I have 1 over, it's just 1 over 3. Let me fill in my table. There we go. Okay. Next one says y equals 3 to the power of 0. What is our rule about the power of 0? Anything to the power of 0 is going to give me? Give me a second. Okay, there's suddenly a lot of noise this side. You guys can probably hear it. Give me a second to move, okay? Derivations. Let's continue. So that is indeed 1. Anything to the power of 0 is equal to 1. Let's move on to the next one. That is y is equal to 3 to the power of 1. And that's just going to give us what? 3 to the power of 1 is just going to give us 3. Okay. And for my last one, y is equal to 3 to the power of 2, which means 3 squared. And how much is 3 squared? Be careful. 3 squared. Nice, Logan. Quick to fix our mistakes. That is 9. Beautiful. Okay. If you guys forgot any of these exponent rules, please go to the lesson that we had on exponents. Okay, let's continue. It says determine the rule in each of the following tables. Okay, now I have a -4, -2, 0, 2, 4, 6. What is happening there with my outputs? What is happening with my outputs? -4, -2, 0, 2, 4, 6. What are we doing with the output, guys? Nice, no, we are adding 2. -4 to -2, you add 2. Okay, so that means 2 becomes my what? What's the special word we use for this number that we add over and over again? 2 becomes your multiplier. Nice. Okay, so let's do the first one, okay? We're going to say 2 times -1. What is 2 times -1 going to give me? Because -1 is my first input. So that's the one I'm going to work with. So 2 times -1 is -2. Is that the desired outcome here? If you look at my output, my desired outcome is -4. So what do I still have to do with this number to get to the desired output? Not add 2. Nice, Logan. I have to subtract 2, which will give me -4. Let's check it with a different one. I'm deciding now we're going to check it with 3. Let's check it with an input of 3. That means it's going to be 2 times 3. What's 2 times 3? That is 6. And if I subtract 2, I get 4. Is that my desired output? Yes, it is. So what is my rule, guys? What is the rule? Y equals nice, guys. Y equals 2x minus 2. Okay, this one is a little bit more interesting. What is happening here? 3, negative 3, negative 9, negative 15. What are we doing here with the outputs? We're not subtracting 3. Look carefully. We went from 3 to negative 3. So that's more than 3. Nice, Yonela. We are subtracting 6. So this time we have a negative multiplier. Do you see that? So let me write it down here. My multiplier is negative 6. Okay. So if we check out the first one, negative 6 times negative 1. What is that? 2 negatives. If you multiply 2 negatives, you get a positive 6. Nice, a positive answer. That's 6. But I want to be at 3, not 6. So what do I still have to do with this answer? Minus 3. And that will give me 3. Let's try it with another one. Let's try it with a little bit of a bigger number, with 11. Okay? I'm going to say negative 6 times 11. A negative and a positive is going to give me what type of answer? A negative and a positive is going to give me a negative. And what's 6 times 11? Nice, Yonela, 66. And if I subtract 3, what's 66? Negative 66 minus 3? Negative 69. So what is my rule, guys? Nice, Logan. Nope, almost. You just missed one thing. One thing you are missing there, Logan. Almost, almost. Y is equal to? Nice. Negative 6x minus 3. You guys are getting good at this. You're getting way too good at this. Okay, let's do a last one and then we'll go to the brain break. Okay, I think we deserve a brain break after this. In this case, we're going to find the rule and then we have to work out one input, which is B, and one output, which is A. So this is a combination of all things that we have been doing today. So let's see, how do we work with this one here? 3, 4, 5, 6. You can't work with 2 to 5, right? That's misleading. So you only can work with the ones that are next to each other. So 3, 4, 5, and 6. What are we adding? This is very easy one. We are adding 3 to 4 to 5 to 6. There we go. Adding 1. Plus 1. Plus 1. Plus 1. Okay? So since we're adding 1, my multiplier is 1. So I'm going to say 1 times negative 1. What's 1 times negative 1? 1 times negative 1 is negative 1. Now, how am I going to get to 3? We're over here. How am I going to get to 3? I have to add 4. Nice, guys. And this will give me 3. Let's test it with another one. Let's test it with 5. 1 times 5, that's going to give me 5. And if I add 4, that's going to give me 9. Is that my desired result? If I use an input of 5, is 9 my desired result? Yes. So what is the rule? Y equals, nice, 1x or just x plus 4. Now let's find A. A is telling us that my input is 13. So do I substitute my 13 at x or do I substitute it at y? Nice. I substituted at x because it's an input. Okay, so y equals 13 plus 4, and that's going to give me how much? Nice, 17. So for B, do I substitute at my x or at my y? Nice, guys. It is an input. So I'm going to substitute to that. Well, 24 is the output. So I'm going to substitute it at y. So then I'm going to say 24 is equal to x plus 4. How am I going to get rid of this 4 next to it here? How will I get rid of that 4? Take it over and it becomes what? If it was positive, it becomes negative. So then x will be 24 minus 4. Therefore, x equals 20. Nice, guys. Beautiful.